Hello, geometry, and welcome to lesson 6, the final lesson of topic 6, covering conditions of special parallelograms. So very similar to what we did with parallelograms, right? We learned about the properties, then we learned ways to show that a quadrilateral is a parallelogram. Well, here in lesson 6.5, we learned about the properties of these special parallelograms, rhombus, rectangles, and squares, and now we're going to use those conditions to prove that they are, in fact, a rhombus, a rectangle, or a square. Okay, so similar to like the idea of like converse. Okay, so question 1, it says information about diagonal can help you classify a parallelogram. In parallelogram ABCD, segment AC is perpendicular to segment BD. What else can you conclude about the parallelogram? All right, so we need to know what that means if they're perpendicular. All right, so since segment AC is perpendicular to segment BD, then all 4 angles at E, angles at point E, are right angles. So we have one right angle box, but again, all 4 of these can be right angles. Thus, angle AEB is going to be congruent to angle CEB is going to be congruent to angle CED is going to be congruent to angle AED. And again, that's because all right angles are congruent, right? So we're doing like sort of like a little proof here, if you will. Okay, so we have 4 triangles, each has a right angle, so that means each has a congruent angle. All right. In a parallelogram, the diagonals do bisect each other. The diagonals bisect each other. So we know that segment AE is congruent to segment CE, and we know that segment BE is congruent to segment DE. So now if you look at these 4 triangles, all of them have a side with a single mark and a side with a double mark. That means that all 4 of these triangles are congruent. Therefore, triangle ABE is congruent to triangle CBE. ABE, CBE is congruent to triangle CDE, is congruent to triangle ADE. And that would be side angle side, side angle side in all 3 situations. So because those 4 triangles are all congruent, all the corresponding parts are congruent, and these outside sides, so AB, CB, CD, AD, those are all corresponding parts. So segment AB would be congruent to segment CB, would be congruent to segment CD, would be congruent to segment AD, and that would all be by CPCTC. And I'm going to put 3 marks on all of those. And that would mean that this parallelogram has 4 congruent sides. And since ABCD is a parallelogram with 4 congruent sides, ABCD is a rhombus. And the point of this problem is, okay, I gave you a parallelogram and I told you the diagonals were perpendicular. Because of that information, you could say that this parallelogram is a rhombus. And this is our first kind of converse of the day, right? So see, it says converse up here, yes? So again, these ideas stem from the previous lesson. If the diagonals of a parallelogram are perpendicular, diagonal is perpendicular, then it is a rhombus. You have to know it's a parallelogram as well, okay, because these are special parallelograms. So again, if you see a picture like this, you know that JK is congruent to KL, is congruent to LM, is congruent to MJ. Another similar idea from last lesson, again, it's a converse. If a diagonal of a parallelogram bisects two angles of the parallelogram, then the parallelogram is a rhombus, right? So again, in this idea, if you have a diagonal of a parallelogram that bisects two angles, then it's going to be a rhombus. So here you have diagonal BD that is bisecting these corner angles, right? So these two angles are congruent, and these two angles are congruent. Then you know that all four sides are congruent. Now you might not know right off the bat that all four of these angles are congruent, right? The picture might have like this and this. So these two are congruent and these two are congruent, but you in fact know that all four are going to be congruent because it is a parallelogram, right? Okay, so be aware of that. Okay, so we're going to do one more humdinger of a proof, okay? I think it's going to be able to prove this theorem right here. Yep, so write a proof for the, it says it's called the parallelogram diagonal bisector theorem, whatever, right? It's the last idea we talked about, okay? So it says, given that we have a parallelogram FGHJ with angle 1 congruent to angle 2 and angle 3 congruent to angle 4. So this is what I was talking about, right? Right now, you know that the corner angles are bisected, but you don't know that all four of those are congruent to each other. You don't. We want to prove that this is a rhombus. So again, we want to show that all four sides must be congruent, right? So in this picture, I think we have to show that, you know, we have these two triangles that are going to be congruent, but we have to be careful about the correspondence, and we'll talk about that as we go through, okay? So again, just going to write down this paragraph proof. So we are given parallelogram FGF, that's an F, not a P, sorry, FGHJ with angle 1 congruent to angle 2 and angle 3 congruent to angle 4. So right now, between these two triangles, we have one pair of congruent angles and two pairs of congruent angles, right? So if you look here, FH is the side that is shared between them. So segment FH is going to be congruent to itself by the reflexive property. So we know that triangle, and this is where the correspondence is very important. So in this case, FGH is congruent to, so angle F corresponds to itself in both triangles, right? Because that's the 1 and 2 are the ones that aren't congruent. So FGH is congruent to FJH. And that'd be by angle, side, angle. Again, once we mark that middle side congruent, the side is in between the two angles. So now from here, right, we know that we have some congruent sides. So because those two triangles are congruent, we now know that segments FG will be congruent to FJ, and let's go HG will be congruent to HJ, and that's by CPCTC. So in this picture, we have FG congruent to FJ, and we have HG congruent to HJ. But now let's not forget that this thing is a parallelogram, right? So aside from these two sets of sides being congruent, I think I also know that the opposite sides are congruent, right? So I know that FG is congruent to HJ. Since FG has one marking, HJ only needs one marking. I know that FJ is congruent to GH, or HG. Again, one marking. So now I know that all four sides are congruent. So this is a big transitive property problem, right? So we have these two, right? So now we're going to say, okay, well, because FGHJ is a parallelogram, segment FG is congruent to segment HJ, And segment FJ is congruent to segment HG. How would I write this? Because those are by opposite sides of parallelogram being congruent, right? Something like that, right? I'm just making it up. Being, that's the word being. If you can't tell, being congruent. So now, if you look here, right? If I do like a little play on, right? So by the transitive property, so if I use these two, so FG is congruent to FJ and HJ, right? So if I do a little substitution, I can say that FG, right here, I can replace HJ with HG. So FG is also congruent to HG. And now what I've done here is I've proven that FG is congruent to all, that's a G, to all the other sides, which means that all four sides are congruent to each other. Therefore, FG is congruent to FJ, is congruent to HG, is congruent to HJ, and FGHJ is a rhombus because all four sides are congruent. And there we go. So congruent triangles, some properties of parallelograms to prove this theorem. All right, so that's our ideas of rhombuses. Next video is about rectangles.